They didn't announce it. There was no press conference, no official statement. But quietly, behind closed doors, a question began circulating in defense and energy circles. Why is the Pentagon reportedly paying attention to a small, controversial energy breakthrough coming out of Africa? At first glance, it sounds impossible. A so-called free energy system, a phrase that immediately triggers skepticism, disbelief, and accusations of pseudoscience. And yet, something about this story refuses to disappear. Because this time, the claims aren't coming from a viral TikTok clip or a garage inventor chasing attention. They're coming from engineers, private demonstrations, leaked documents, and whispers of observers who weren't supposed to be watching. To understand why this matters, we need to rewind. For decades, Africa has been portrayed as an energy-dependent continent, rich in resources, yet struggling to convert them into stable power. So, when reports emerge of a device allegedly producing continuous energy without conventional fuel, most dismissed it instantly. Scientists scoffed. Comment sections exploded. The word hoax spread faster than the story itself. But behind the noise, something unusual happened. Instead of vanishing, the technology began attracting quiet interest. Not endorsements, not confirmations. Interest. According to multiple sources, demonstrations were conducted away from cameras. Observers weren't influencers. They were engineers, analysts, and energy consultants. Some walked away unimpressed. Others asked to see it again. And that's where the Pentagon enters the conversation. Because for defense agencies, energy isn't just about electricity, it's about logistics. Fuel convoys are among the most vulnerable assets in military operations. Bases require massive, constant power. Every gallon of fuel moved costs money, time, and lives. So when any technology claims to reduce or eliminate fuel dependency, even if it sounds unlikely, it gets noticed. Not believed, not accepted, but noticed. Especially when the source isn't a Silicon Valley lab, but a region historically underestimated. What makes this situation more intriguing is what hasn't happened. There has been no public dismissal from defense agencies. No official debunking. No press release saying, "This is nonsense." Just silence. And in intelligence circles, silence can mean one of two things. Either something is too insignificant to address, or it's too sensitive to talk about publicly. Meanwhile, the inventor at the center of the controversy continues making bold claims, claiming his system taps into ambient energy fields, resonant frequencies, and principles not yet fully embraced by mainstream physics. Critics argue these ideas violate fundamental laws of thermodynamics. Supporters counter that history is full of breakthroughs once labeled impossible. Radio waves were once fantasy. Flight was once ridicule. Even nuclear energy was once dismissed as theoretical nonsense. But here's the critical difference. Those technologies eventually survived independent verification. And that's the line this story hasn't crossed yet. Which raises the real question. If this technology truly doesn't work, why are serious institutions still watching? And if it does work, even partially, why hasn't it been replicated publicly? Because according to insiders, the most important detail isn't the device itself. It's who gets access to the data. Because once data enters the public domain, control disappears. And control, not innovation, is often the real currency in energy geopolitics. According to analysts familiar with defense research protocols, any technology that even suggests reduced fuel dependency triggers a quiet evaluation process. Not to validate the inventor's claims outright, but to answer a more strategic question. If this worked, what would it change? The answer is unsettling. Military bases that no longer rely on supply chains. Remote installations operating indefinitely. Disaster zones powered instantly without generators or fuel drops. Even a fractional improvement in energy autonomy would be disruptive. Which is why the alleged observations didn't happen in public labs or university halls. They happened in controlled environments, with limited access, where results could be analyzed without headlines forcing premature conclusions. Sources claim that during one such observation, the focus wasn't on whether the device was free energy, but whether it demonstrated anomalous efficiency. Because in real-world science, revolutions rarely arrive fully formed. They arrive as anomalies, measurements that don't quite add up, losses that appear too low, outputs that demand a second look. Critics insist that any perceived anomaly can be explained by hidden inputs, measurement error, or misunderstanding of power accounting. And historically, they're right, most extraordinary energy claims collapse under scrutiny. But defense agencies don't assume collapse. They assume risk. Risk that dismissing something too early could mean missing a strategic shift. This is where Africa's role becomes impossible to ignore. For decades, innovation narratives have flowed one way, from Western institutions outward. But this story flips that assumption. An inventor operating outside elite academic systems. A region not traditionally associated with frontier physics. And a device that refuses to fit neatly into existing categories. That combination alone creates discomfort. Because it challenges not just scientific models, but institutional confidence. Meanwhile, online discourse grows more polarized. Supporters frame the silence as proof of suppression. Skeptics see it as evidence of irrelevance. And the truth likely exists somewhere in between. What's certain is this. No government agency builds policy on YouTube videos. If interest exists, it exists because someone saw something measurable, even if inconclusive. And that brings us to the most misunderstood part of the story. The Pentagon doesn't need the device to work as claimed. It only needs to work better than expected. Better efficiency. Lower loss. Unusual behavior under specific conditions. That's enough to justify monitoring. That's enough to justify analysis. That's enough to keep a file open. And as long as that file remains open, the story doesn't end. Because somewhere between outright hoax and world-changing breakthrough lies a gray zone, a place where unanswered questions live. Questions like, why has no independent, fully transparent replication been completed yet? Why do demonstrations remain controlled and selective? And why do some observers leave unconvinced, while others request follow-ups? Until those questions are answered publicly, speculation will continue. But one thing is already clear. Whether this technology succeeds or fails, it has exposed something deeper, a global discomfort with where innovation can originate and who gets to define what's impossible. Because the moment you label something impossible, you stop investigating it. And institutions that deal in national security can't afford that luxury. What happens instead is quieter, slower, far less dramatic than the headlines suggest. A technical note is circulated. A small group is assigned to review available data. Questions are framed very carefully, not, is this true, but under what conditions could this appear true? That distinction matters. Because even flawed demonstrations can reveal useful ideas. New coupling methods. Unusual signal behaviors. Design shortcuts that weren't considered before. And this is where the story takes another turn. Some engineers who reviewed the footage weren't impressed by the claims. They were intrigued by the architecture. The way components were arranged. The way losses were allegedly minimized. The way energy transfer was described, even if the explanation itself was incomplete or wrong. History is full of breakthroughs born from incorrect theories but clever execution. Early flight models used bad physics and still flew. Early radios worked before anyone fully understood signal propagation. Even modern batteries were commercialized before their chemistry was completely mapped. So the question shifts again. Not, is this free energy? But is there something here we don't fully understand yet? That question doesn't belong to belief systems. It belongs to laboratories. And laboratories demand repetition. This is where critics regain solid ground. Without open testing, without independent instrumentation, without transparent accounting of every input and output, there is no scientific validation. Full stop. Which is why some physicists dismiss the entire subject outright, not out of arrogance but exhaustion. They've seen too many perpetual motion claims collapse the same way. And yet, a few remain cautious. Not optimistic. Not convinced. Just unwilling to close the book too early. Because dismissing a claim is easy. Proving it wrong under every possible configuration is much harder. That's why no official statement confirms interest, and none denies it either. Silence is safer. Silence avoids amplifying unverified ideas. Silence avoids legitimizing speculation. Silence keeps options open. Meanwhile, the inventor continues to demonstrate, selectively. Supporters say it's protection. Critics say it's control. Neutral observers say it's a red flag. All three can be true at the same time. And as long as the demonstration stops short of full disclosure, this story remains suspended in a strange place, neither breakthrough nor bust. But here's the part most people miss. The real impact may have already happened. Not in labs, not in military files, but in perception. Because millions have now seen a narrative where Africa isn't just consuming technology, it's claiming to redefine it. That idea alone is disruptive. It forces conversations. It challenges assumptions. It provokes both hope and hostility. And in the history of science, moments like that often come before clarity, not after. Which raises the most uncomfortable question of all. What if the reason this story refuses to die isn't because it's true, because ending it would require transparency at a level no one has yet delivered? Not the inventor. Not independent reviewers. Not governments. Not critics. To truly end the debate, the device would need to be placed in an open environment, stripped of mystery, stripped of narrative, stripped of control. Every wire traced. Every signal measured. Every field mapped. Every assumption challenged. And that hasn't happened. Instead, what exists is a gap. A gap between demonstration and verification. In that gap, stories grow. Supporters fill it with hope. The idea that centuries of centralized energy control could finally be disrupted, that regions long dependent on imports could leapfrog straight into self-sufficiency. Skeptics fill it with warning, that extraordinary claims without extraordinary evidence don't just mislead, they distract, pulling attention and funding away from real, incremental progress. And institutions? They sit exactly where institutions always sit when something sits in the gray zone. Watching. Because even if 99% of such claims fail, history shows that ignoring the 1% can be costly. So the monitoring continues. Not loud, not official, not public. Just enough to ensure that if something does cross the line from curiosity into capability, it isn't missed. Meanwhile, the online battlefield grows louder. Every new video is dissected frame by frame. Every cut is accused of deception. Every success is labeled staged. Every failure is labeled hidden. And the truth becomes harder to hear, not because it doesn't exist, but because it's buried under certainty on both sides. What's rarely discussed is how fragile innovation actually is at this stage. Breakthroughs don't emerge cleanly. They wobble. They contradict themselves. They attract the wrong explanations before the right ones arrive. But fraud follows the same pattern, right up until the moment it collapses. That's the tension holding the story together. Two paths. Same surface. Different endings. And right now, no one outside a very small circle has enough information to say which path this is on. Which means the real story isn't about free energy at all. It's about process. Who gets to test? Who controls the data? Who decides when something is ready for scrutiny? And who benefits from keeping it just out of reach? Until those questions are answered openly, the Pentagon rumor, the lab whispers, the viral demonstrations, they all remain what they are now. Signals. Not proof. Not lies. Just signals. And in science, ignoring a signal can be as dangerous as believing it too quickly. That's why this story doesn't end here. Because that edge is where decisions quietly begin to form. Behind closed doors, engineers don't argue about headlines, they argue about margins, about noise floors, about whether a signal could be environmental, induced, or deliberately introduced, about whether a system is harvesting something mundane and being framed as something miraculous. That's the uncomfortable middle ground, a place where wonder and skepticism coexist. And it's also where reputations are made or destroyed. If the technology is real, even partially, then delaying full verification risks losing control of the narrative, or worse, allowing others to replicate it first. If it's not, then every additional demonstration increases the eventual backlash. That's why progress here feels slow. Because moving fast is dangerous. A single open test could end everything in either direction. And yet, pressure is mounting. Investors want clarity. Scientists want access. The public wants answers. Even supporters are starting to ask harder questions, not because their belief is fading, but because belief alone can't carry a technology into the real world. At some point, prototypes must become procedures. And procedures don't care about stories. They care about repeatability. So now the question isn't whether the world is watching. It's who will blink first. Will the inventor open the system fully, risking exposure but gaining legitimacy? Will an independent institution step forward with controlled testing and published data? Or will the narrative simply outpace the technology, collapsing under its own weight? Every path leads to a different future. In one, this becomes a footnote, another cautionary tale about how badly people want miracles. In another, it becomes something far more disruptive, not because it breaks physics, but because it reveals we misunderstood a small but crucial piece of it. And history shows us something important. True revolutions don't announce themselves clearly. They arrive confused, contested, messy. They are doubted loudly and understood quietly. Which is why, even now, no final verdict exists. Only a tension that refuses to resolve. And until transparency replaces speculation, this story doesn't conclude. And that is where we leave it. Not with answers. Not with conclusions, not with certainty, but with a clear dividing line. On one side is belief, powerful, inspiring, and dangerously easy. On the other is evidence, slow, unforgiving, and ultimately unavoidable. If this technology is real, it will survive scrutiny. If it isn't, scrutiny will end it. There is no third outcome. Until transparent testing replaces controlled demonstrations, until data replaces declarations, until replication replaces reputation, everything you've heard remains a claim, nothing more, nothing less. So the question was never whether the Pentagon is watching. The real question is whether the truth, when fully exposed, will be powerful enough to stand on its own. Because in science, in engineering, and in history itself,